All right, guys, welcome to another KevCAM night class tonight. Tonight I have Mr. Steve Welsh helping out. Steve, are you there?
I am. Welcome, everybody. We're happy to see you attending the KevCAM class tonight. Thanks for attendance.
Yeah, and definitely see a lot of people in here tonight, so and definitely see some new names in here. So kind of how do we do the night classes is we use GoToWebinar for those of you guys that are new. And sorry, guys, for those of you guys that have watched every one of the night classes, but so we use GoToWebinar. Everybody is currently in mute. Let's just eliminate any background noise. And if you guys do have questions, there is a questions field, and definitely these classes are solely dedicated for you guys for a learning experience. So ask away, and Steve will stop me in my tracks, and we'll get those questions answered for you right away. Tonight we are covering 5-axis parallel cuts. No, last week we kind of, Justin and I went over the buttons of what everything kind of does inside there. And like I was telling you guys last week, we're going to kind of take this 5-axis in baby steps just because there's so much there. Technically, we could probably be working on 5-axis for the next year on the night classes here, guys. But I'm going to try to go through it, give you some good examples, more focusing on the tool axis direction and some of the Gouge Check stuff there. So I guess with that being said, let me get my good old splash screen up here for your guys' ideas. And cancel this. And so these classes are, like I said, solely dedicated for you guys. Any video suggestions that you guys have or whole night classes, send them over to me in an email, and we'll send you some SolidCAM swag. For those of you guys that are new, we are not shy of making videos on my channel here. So if you guys just go to YouTube and type in SolidCAM University, a lot of stuff in here. Doing the night classes in here up to, a quick little 3 to 5 minute videos, even some live cutting right here. This one seemed to be a pretty good traction. We call this our popcorn machine. It's just a tiny little machine here. It's got a 0.9 horsepower. And it was actually designed for cutting wood, and we are blowing it out of the water cutting 17/4 stainless steel here with a, I think a 3/16 inch end mill, so pretty interesting there. But lots of stuff in here for you guys. For those of you guys that are kind of new to maybe the YouTube side of things, if you guys go to my channel, don't hit the search up here. You guys want to come down to the search icon right here, and you guys can actually search for anything inside the channel right here. So this is real beneficial here because we're getting quite a few videos in here now. We've been going at this about a year now, and it's been, getting a lot of good positive feedback from you guys. So, and like I said, if you guys have those ideas, send those over, and we'll get those uploaded for you guys. So,
hey, Kev, can I just chime in quick on the popcorn machine?
Yeah.
Yeah, that really was a small little desktop, almost a router. And just wanted to mention that we did a full-on retrofit spindle and controller. We're partnered up with a real good outfit that, boy, can make a old, tired piece of equipment just sing. So I guess the reason I mention it is, we consider ourselves software gurus first and foremost, but keep us in mind for recommendations on, all things machining, tools, holders, spindles, controllers, things of that nature too. And this is a fun machine. If you ever find us at a trade show, we typically have this running, and people are amazed of what we're doing with basically a desktop reconditioned router.
Yeah, so. Yeah, it's a great point there. And the nice thing about this too is at the trade show, we were telling everybody this was a 2 horsepower spindle, and come to find out it was only a 0.9 horsepower right. Spindle, so it was even more impressive that way. But yeah, and like Steve's saying here, I did this video right here. We're doing a testing on a Goering diver tool. Our plan, well, my plan on this tool was I wanted to snap it off and see what it could take, and it handled it. So definitely, and we're going to be doing coming up. We were talking about tool holders when we had Scott Neal on here for your guys' molds, and I was telling you guys about the RegoFix holders, and we've had the best luck with those RegoFix holders. We're actually going to do a night class on that, or maybe not. It's kind of up to you guys. I'll kind of leave it up to you guys. If you guys want to do a night class on that holder, or we can just do kind of like a product review like I did with the 3D space mouse down right here. But like Steve said, we're not just here going to teach you guys software. You know, full machining experience. I've got the least amount of experience in the company. I've been machining since 2000, so we got a bunch of old dogs that have all those great tricks in their back pockets for machining. So, and with that being said, I am going to, for those of you who don't have my email address, I just put it into the chat area. And for those of you that just want a direct link to the YouTube channel, I will put that in there also. And that will take you right to the YouTube channel there. So, okay, so Ronnie's asking make and model of that machine. Jeff, if you're there, I sent that information over to you. Jeff, do you remember right offhand what the name of that machine was? I can't think of, I'm trying to think right now, and I would have to search through my email to find it. I actually got. I
can't remember either, Kevin, sorry.
Oh, Jeff said he's going to get it. So Ronnie, we'll get it for you. I think we have maybe about $5,000 into this machine total after the retrofit and everything. So I know that you're asking, and I'm not sure of the availability, Ronnie, on it, but I will shoot me an email, and I'll get the information off. And this is Ken Merritt right here. For those of you guys that don't know, this was at just one of our trade shows. But Ken actually kind of got this machine up and rocking here. So,
Kev, if I'm not mistaken, I almost want to say that machine was a cast-off. I don't think we even paid anything for it.
Oh, didn't we? Yeah, well, that's right.
It was the machine. It was a cast-off, but then the retrofit, you know, cost us a little bit of money. Yep. But yeah, you know, I guess the point in bringing that up, gentlemen, is really that, boy, with iMachining, the technology we offer, it's a lot less expensive to maybe get an older piece of equipment up to speed than having to buy a brand new one. And I know that'll piss off the machine tool resellers, but boy, instead of having to maybe trade out an older machine, you can really get some good performance if you maybe upgrade the controller and the spindle. Far less expensive to do it that way than buying a brand new piece of gear.
Yeah, absolutely. And if I just go down here, I just want to make sure I didn't put the, yeah, I'll have to put the machine manufacturer in here, but yeah, 0.9 horsepower, 20,000 RPM at 246. Defiance.
There it is. Yeah.
Yep. Thanks, Jeff.
Yep.
Yeah. So Ronnie, it's a Defiance machine, but like I said, Ronnie, shoot me an email as a reminder, and I will get you all the information you need for that. So. Yeah, so it's a Defiance VTX-1, and like I said, it's kind of specially made just for wood. But we did 246 inches a minute, cutting that 17.4 stainless with a 3/16 4-flute MA4 tool. So really kind of cool there. Okay, got off on a little tangent there, but that's great. Love doing that. Okay, so let's get into. All right, Jeff, what do you got here? Did Genonics Creative Evolution do the control system upgrade? No, Mock Motion did the upgrade.
Yep.
Or they gave us the products and we put it in. So, okay. So let's get into parallel cuts. Now, like I was saying before, guys, is 5-axis is identical to HSS. So 2 ways of going about it, and I have the bad habit of always coming over here doing add milling just because I've been using SolidCAM so long and we didn't used to have the toolbars up here. So I'll get up to, let's see, where's my ribbon that I'm looking for? Multi-axis, simultaneous 5-axis here. Okay, so we're going to do our parallel cuts here. Same thing as HSS. The only thing that we're missing is our constant Z and linear and in here, but so we're going to do our parallel cuts, grab our geometry. So right now I'm going to cut the surface right here. You know, you guys can put drive, surface offsets, all that stuff in here, just like HSS, so I'm not going to dig too deep into it. Kind of want to get more into showing you guys the different parts with different angles and all that stuff. Levels, we'll just go with that for right now. Toolpath parameters. And holy cow, it's hailing outside. Sorry. So we'll go to, I'm going to leave the step over fairly large for right now and go to sorting, and I'm going to do a spiral. So it's basically going to start at the top and just do a spiral working its way around. So let's just go to our tool axis control now. Now, it's going to be defaulted to tilted to relative cutting condition, orthogonal to the cut at each position, meaning, you know, orthogonal 90 degrees to each position of that surface there. Now I can put different leg angles. I can do a side shift on here. So let's just see what we have. Do a quick save and calculate. And right now I'm coming through my part. You guys can see that my toolpath, this is actually starting down here. So that's going to be in our levels. So let's get our plane height. Let's just set, see where that gets us here. There we go. That looks better. So now what we're doing is we're coming in here with the cutter and coming in, and it's right on 0. So right working on the tip of that, the cutter. So let's just do a simulation. And, you know, for the 5-axis guys, we're going to be doing a lot of solid verify and a lot of machine sim. Just because, you know, showing you guys the toolpath here looks all nice and pretty, but I can't really tell where my tool is tilting at this point. So if we just do a solid verify real quick, and let me slow this down, and you can see it's basically the tool is 90 degrees to that surface, working right on that ball. Now, as it gets farther down into the surface, you'll see that that tool automatically changed and moved over, and now it's at a different tilt angle right now. So let me kind of speed this up here a little bit. And now when we actually get down to the bottom radii right here, it's going to tilt back up for us. So we'll kind of play this through here. I don't want to go too fast for you guys, but so now we should see our tool, see how it kind of starts tilting back up there. Let's look at this with machine sim. And I just have this on a Haas UMC 750 here, so let's kind of get buzzed in here, and we'll kind of slow it down here. So we're kind of working right on that top radii, and you'll see the head, the 5-axis trunnion rotating up to work more on the side now, keeping that tool tip at 90 degrees to that surface. And now we can kind of speed it up just a little bit here. And I'm going to turn off my machine shroud here. And then once we get down to that bottom radii here, you'll see we kind of flatten out. So great tool path right there. Now, personally myself, I don't like working right on the tip of the ball. We can get a much nicer finish if we can use more of the side of the cutter versus the tip. Get more those the side cutting of the flutes being used versus having just cutting right on the tip of that cutter. So what I'll do is I can come over here and change my leg angle, and let's just do 20 degrees right now. And the toolpath is basically going to look the same. So like I said, we're going to be doing a lot of machine sim and solid verify to just get a sanity check on what's going on there. So let's just go back to our machine sim here. And we'll get kind of zoomed in here. And go ahead and play it. Now, you'll see, let me just kind of pause this here. You'll see we're actually cutting on 20 degrees trying to get a good 20 degrees right here. So we're not working on the tip anymore, but we're working on the side of that ball right now. And like I said, more personal preference, but I really think you guys get a much cleaner, nicer finish when you're using on the side of the cutter versus the tip. Let's do a solid verify real quick here. And I'm just going to kind of hold my space bar here. So we can kind of see, let me kind of get control here. There is a good representation of kicking that over at 20 degrees right there. So does it kind of make sense for everybody? Kicking that over, you know, at that 20 degrees right there. And we can go more. Let me get a good shot here for you guys. And then we kind of tip up and clean up that radius. Now, you know, and you guys may be saying, well, you don't have a nice finish. Well, you guys got to remember, I do have my step over set at 50 thou. So now, like I've been saying all along with HSM, HSS, and now on 5-axis, leave that toolpath parameter as your surface quality. Leave that to the absolute last thing to do. Like I said, you're going to save yourself calculation time. Just get the toolpath looking the way that you want. Make sure, you know, your head's rotating, everything is, you know, jiving correctly. It's a lot easier to look at a toolpath when it's spaced out and see what's going on here versus if we have, you know, a solid green line right here. So let that be the last thing, and now we can, you know, I can crank that down to, you know, do a 10 thou step over and, you know, really get a really nice finish on there. But like I said, kind of more user preference on legging that over. We could actually do a side tilt too, and we can actually lay this over more than, you know, 20 degrees. It's completely up to you, but I've kind of found, and, you know, correct me if I'm wrong, I know, Jeff, you do a lot of 5-axis, and a lot of you guys do 5-axis, but I kind of found that 20 degrees kind of be the sweet spot. And if I go too far, then I'm going to start running into, you know, a holder against the part. So any questions with this part right here, guys? Just kind of getting the ball rolling here, and we'll get into some more complex stuff right here. All right, looks like we're good. And we still have more people hopping in here. Very nice. Okay, so let's go ahead and hop out of here. And let's go to our next part here. And I am looking for, okay, so this part actually you guys have currently in your arsenal. If you guys go to your, let me just pull up the path here for you guys. If we go to your, get down to my computer here, see user public documents, SolidCAM, and whatever version you're running, user and getting started examples under SolidWorks. It is right, the 5-axis right here. So if you guys want, you guys can definitely check this out. And if you guys want any of my parts that we're working on here, just tell me which parts you guys want, and I can upload them onto the cloud and get you guys a link. So just let me know. But I'm changed this one around just a little bit here. So what we'll do here is do another parallel cuts. So let's just do 5-axis here. We'll go ahead and grab our geometry. And grab this little radius right here. Okay, so we'll use that as our drive right there. Now what I'm going to kind of do is doing a little bit of a roughing strategy and kind of work my way from larger tool to smaller tool. Now with this one, I'm going to be using a bull nose end mill, not a ball, a bull. So we have a 4mm radius on a 16mm cutter there. Levels. Now last time, since we were kind of working on a more of a square part, I did a plane, but now since we're working on a more circular part, I'm going to switch it over to cylinder. And it's asking the radius, so we'll do 40 right now, should be good. Toolpath parameters, let's just put this at large for right now, 5, and let's do a spiral. Now, let's get into the guts of things with the 5 axis. So tool axis control, I'm going to do tilted to cutting condition. But now what I want to do is follow the ISO lines, and let's just see what that gets us right now. Let's just do save and calculate here. Okay, so now you can see I'm coming right up to the edge right here. If I was to play this through, let's just do a quick solid verify here. I'm going to kind of play this one a little fast here for you guys. I'm working on the flat of the end mill, of the bull nose end mill there. Definitely not going to get the nicest finish doing that route. So first thing I'm seeing is I'm going to want to kick that over on do a 20-degree leg angle. But one other thing I want to show you guys here is, we'll get in a little more kind of advanced on this part here, is our gouge check. And we should be crashing in here. So yep, we'll just say continue, stop, and you can see we got a little bit of a issue there. So let's go ahead and turn on our gouge. So let's go ahead and go to our gouge check here. And I'm going to enable my first one as my drive. And let's uncheck the surfaces, and I want to do against my arbor and my holder. And then I'm just going to leave it on retract tool. Now if I go to my gouge 2, enable this, and we're going to do our holder and arbor, and I'm going to do my check surfaces this time, and I want to do the back of my part and right there. Now the reason I picked my fixture there is because, as you guys were seeing, the holder was hitting that surface there. So by telling it to not touch that surface, and just basically I want to stop the calculation. So let's just do stop toolpath calculation, and I'm going to do a stock to leave of 0.2 millimeters. Let's do save and calculate here. Oh shoot, I forgot to kick that cutter over to 20 degrees leg. So now we're coming in there, and you'll see our toolpath isn't getting as close anymore. So let's go ahead and go to our leg angle right here, and let's just do another 20. And we should see pretty close to the same toolpath here, but now we're going to be working on the side of that ball versus the flat of that surface. So let's just see what we have so far here. Play it through here, and let me just kind of pause it right here. You can see, and I'll just kind of slow it down here, and you can see that we're not working on that flat anymore. We're working more on that ball surface, kicked over to that 20 degrees for you guys. So we'll let this get up here. And basically I just want to make sure I've kind of cleared my holder now. And then as you guys are programming this, especially with your gouge check, you guys will notice that your gouge check automatically defaults to not have the holder in there. And what you guys can do is you guys can change that. So you can see we don't hit our holder anymore, which is good. But getting back to that, let's say you guys want your holder and arbor always to be checked. All you guys have to do is basically just kind of get the logistics down of, you don't even have to fill out the toolpath parameters, but just come in here and check all these and save that as a template. And then when you guys, and I made a video on this, so I don't want to get in too deep here, but then what you can do is set that as your default template. So every time you go to add a simultaneous 5-axis, everything's already checked for you, so you don't have to check everything that's going on there. Okay, so now I think I can get in there just a little bit deeper if I tilt my cutter off, let's just say 20 degrees also. So let's just kick our cutter over. So now we're working on the ball, but we're leaning off to the one angle. So let's just save and calculate here.
Kevin, what would be some instances when you wouldn't want all those checked? If you had a real basic toolpath, or
like that,
just for speed?
Yeah, that first initial one, I didn't have any, I knew I wasn't going to be running into any fixtures, any walls, anything like that. So I didn't even need to do a turn on the gouge check and have that stuff on there. So it all depends on the application for you guys.
Yep.
Now on our last part here, we're going to get really deep into the gouge checking side of things, just because we're going to be doing basically, well, I'll just wait till we get to that point. So now that I kicked that side angle over at 20 degrees now, you'll see that I was able to get my toolpath a little bit closer in there, which is, get more of that material out of there. Let me just pause this for a second. Let's go to my general here and let's bump this up so you guys aren't waiting. Oops.
Kevin, this is where a 5-axis simultaneous machine can really save you a little time, right?
Oh, absolutely.
Because you have so much more flexibility.
Yep. So now you can see we were able to get that tool even farther in there, and you can see now I'm kicked over at the 20 degrees, to the tilt, but also we're tilted 20 degrees this way also, so kind of coming down. And we can, I can kick that over just a little bit farther, but I'm really not going to get too much closer in there, just because, I'm going to start running into my holder here. So I would say for right there is good. So what I'm going to do now is I need to get a little bit farther into here. So what I'm going to do is I'm just going to do a save and copy here. I'm going to switch my tool over to my next size smaller tool here. Now what I'm going to do is, since I only want to work just on this portion over here, the rest of this I already have done. I want to kind of finish working on this area here. So what I'm going to do is, instead of doing full avoid cuts at exact edges, I'm going to do by 1 or 2 points. So I want to do a point from, let's just say right there, up to right here. And let's just go ahead and save and calculate here. And you can see, let me turn off the toolpath, I'm only cutting, just kind of finishing up what's going on right there. So if we go to our tool axis control, tilted relative to cutting condition, maybe let's just try doing this at 10 degrees here, and let's switch this over to orthogonal to each position. And I think that should be it. Let's just see if we can. So we moved in just a little bit closer by doing that. Now what I can do is come over here and set my step over to just 1 millimeter. And now you can see kind of cleaning up where we couldn't get in there before. So, like I said, kind of nice, kind of limited just to working on just this area, using the limit by cuts right there. Let's just see if we can do anything more just to get in there just a little bit more. But let's just kind of take a peek and see what it looks like. And here I'll get it so it's showing, whoops, every step for you guys. So we're looking good there. Able to kind of clean up where it kind of left off at with that previous tool. And I could bump that over just a little bit more, but now what I want to do is finish off the entire part right here with a finished tool. So what I'm actually going to do is, let me turn off this one. I'm going to open up my first initial operation here, and I'm going to do a save and copy. And I'm just going to kind of drag this one down here. And I'm just going to switch this over to my smaller end mill here using a 8mm. And levels still should be good. Toolpath parameters. Let's just set this, well, I'm going to leave that open for right now, and then we'll tighten that up. So we'll just do a tool axis control. I'm going to kind of leave everything the same here. The only thing I'm going to do, yeah, everything looks good right there. Let's just do save and calculate here. So now I'm able to get up even closer since we're using that smaller 8mm end mill in there, or bull nose end mill. So everything kind of looks good here. I can play it through Solid Verify, but I know the last thing I want to do is get a nice finish here. So I'm just going to do a 0.5, save and calculate here.
So Kev, you do kind of employ that same strategy of a loose tolerance up front to get a tool path you like, and then tighten it down, even in 5-axis? Okay, cool.
Absolutely. Just because, you know, now that we're looking at this, it's really tough to see what my lines are doing in here. You know, and you're going to get a little bit, it takes a little bit longer to calculate and a little bit longer to simulate here, but at least when I have it spaced out farther apart, I can see kind of what's going on there.
Nice.
Let's just go ahead and, I won't play this one all the way through the Solid Verify, but we'll get real close here. I think we'll get more into the machine sim. And so now we're, like I said before, let me kind of pause it right there. You know, we're doing a side tilt of 20 degrees and a leg of 20 degrees. So we're working not on the tip of the cutter, but we're actually using the side of the cutter. So you can see it, you know, we've got nice good clearance in there, working its way around the part here. And let's just go ahead and do a machine sim on this one. Okay, getting everything loaded up here. Now, I want to throw this as a teaser out to you guys. This is kind of still in development stages, but I know, Ronnie, you use a G-code reader, but have any of you guys worked with Vericut, where basically it reads the G-code instead of kind of reading the operation? Do we have anybody in here that uses Vericut? Jeff uses Vericut? All right. For those of you guys, like I said, this is still being in the works. I kind of heard a little birdie talking about it. We are going to be able to come up shortly doing the same thing as what Vericut does inside SolidCAM. So it's actually going to be reading the full G code, showing you guys every single step. So you'll see, like right now, when we started a machine sim right here, it already kicked up the table before we even had everything pulled up. What it's going to do, it's going to show you each individual step in there. And I'm trying to think what there's an additional program that we're running in there to help it. And I can't think right offhand what it is, but it's basically going to be, right now it's going to be reading certain lines of G code, but with talking with the post team and the developers, they are going to get it so you guys can read a full G code, which is really impressive, because I think Vericut is, and Jeff, maybe you know more better price. I want to say around $15,000 to $20,000 for Vericut. And then with Vericut, you really have to import all your models in there. There's a lot of transition work going from SolidCAM, G-coding out, bringing it into Vericut, getting all your models aligned and all that stuff. Where ours is already going to be all built in for you guys, and it's pretty cool. So just want to kind of share that with you guys. Don't tell anyone.
Hey Kev, I was sleeping at the switch. Sorry about that too. The video might have been slow a little bit for some people. We just maybe ask, is the video keeping up for everybody on the meeting tonight?
Yeah. Okay. Good.
Okay.
Well, video's laggy, a little choppy.
Yeah.
Let me just look at something real quick here. We are getting some kind of crazy weather going on outside.
Getting some weather that might be doing a little something, Kev.
Let me just run a speed test for you guys here. I'm getting good speed, so I apologize for if we are getting a little lagging going on here. Looks like I got good internet speed currently, but I don't know, maybe it's just something with the GoToMeeting that's causing it too, but apologize for that. And if I'm missing anything or if you guys aren't seeing something, just let me know and
type in a question for sure.
Yep. And Ronnie, thank you for that. So Ronnie was saying he for Vericut was $23,000. From what I hear, this module that we're coming up with is under $5. So pretty cool. And like I said, there's no transitioning, there's no taking, going out in there, and I just want to throw that out there. It's not ready yet, but just as a teaser for you guys, kind of like to share that cutting edge stuff with you guys. But okay, so let's go ahead and play this guy through here. I'm gonna run a little slow here. So you can see we're kicked up at that 20 degrees here, and also working on 20 degrees of the side of the cutter here. So you can kind of see everything. Let me kind of speed it up just a little bit for you. You can really see that trunnion really doing a lot of work right there, and you really guys are going to get a real nice finish. Since we're using that side of the cutter there, using kicked over that leg of 20 degrees and side tilt of 20 degrees, so you guys have a ton of control in here. I love it. Ronnie said we made his day, so that's awesome. But yeah, it's I mean, real cool. And you guys, you can see right here, I really didn't have to do much with what's going on here. Basically, just picking my geometry and picking that what tilt direction. Now, there's a lot of different ones in there. And like I said, with the 5-axis, we could be talking about this for a year straight on what all the strategies do. What I'm going to try to convey to you guys in these night classes when we're covering 5-axis is kind of the more common ones that we're doing. Now, if you guys have a real complex one and we need to get into the nitty-gritty of the 5-axis, then definitely give us a call on the support line, or we can set up a training session. But I'm kind of trying to cover the ones that I would use most, and the ones that are going to be used most common for you guys, and show you guys that toolpath there. So okay, any questions with this part right here? Show the machine everything kind of going back and forth right there. But all right, so in Machine Sim for 5-axis, I find tool changing the machine mode tool focus can be really helpful when looking to an interaction with the material long before. Okay, so in machine, changing the machine mode to tool focus. Tool focus, are you talking the Machine Sim, Jeff? Trying to find, so right now, oh, there we go. Yeah, that's definitely cool. I guess I've never really even played with that, Jeff, so thank you. But this almost kind of looks more along the lines, let me kind of play it through here again, of kind of like solid verify. Because we're not seeing the rotary go around, but yeah, definitely another way of verifying stuff and kind of get rid of all the other stuff there. Time mode here. Let's see, mode. Machine. There we go. So we get back to normal here. So yeah, a lot of different options in here. And so yeah, if you guys are looking for just a little bit more of a simplified, looking straight down on it, that's a great way of doing it. So thanks, Jeff, for that. Appreciate that. Okay, any other questions with this part before we go on to the next one here? Okay, got some really cool ones coming up here. SolidCAM, do a recent, and I want parallel cuts part 1. And looks like I got out of sync here, so let me just calculate real quick. Okay, so right now, let me just kind of show you guys what we currently did here. Let's just do machine sim. This is on a Zigzag Integrex here. So we got our stock, and let me just kind of slow this down, facing off the part, and getting our basic shape of what's going on. This one's kind of a little bit of a mill turn also, but it's kind of what we'll be showing is more of the 5-axis side of things. All right, so we go to cut it off. So now what we're going to do is we're going to be cutting this 5-axis portion, and let me turn off our toolpath here. And for those of you guys that didn't know, if you guys have all these selected, and I only have 3 right now, but let's say you guys calculate something and you guys have it set so after calculation it automatically checks these for you. Instead of going through each and every one, if you guys want, you guys can just uncheck the operations right here and that will turn them all off for you guys. I'm not sure if you guys knew that or not, but that option is there for you guys. Okay, so let's do our simultaneous. So let's just do our parallel cuts, geometry. Just going to work on this outside surface here. And let's go ahead and grab a cutter. Using a 1/4-inch ball end mill. Levels, let's set it to cylinder and good. 3 inches there. And toolpath parameters, let's go ahead and do a sorting. Spiral looks good. And let's go to tool axis control. I'm just going to kind of leave everything default right now. Let's just do save and calculate and see what we got here. Looks good. The only thing that I can see right offhand right now is I'm starting on this side and I want to be starting over here. The reason I say that is we do a simulate, and let's pull up our machine sim here. We're actually doing this on the sub spindle. And let's just go ahead and play this through here. And I have my machine sim is not showing me the correct thing here.
Yeah, where's the spindle?
Yeah, it's there. It's right there, but I got this little piece that's showing off here. Okay, let me switch this over to I know I have an Integrex.
I think you should go to Jeff's mode.
All right,
I bet Jeff's mode's got to be a little easier on the computer too. Resource.
Yeah, absolutely. Let me just, I got to feed rate too high here, so let's just do 1,000. Okay, let's try this machine sim here. Nope, I have something going on here with my machine sim with this Integrex machine. So let's just go to Solid Verify for right now and play this through. So you'll see I'm starting where my spindle is here, and I want to kind of reverse that. I want to start on the outside. Easy enough. Let's just hop in there real quick. And let's go to our toolpath parameters, sorting, and I'm going to do my flip step over. Save and calculate. So now you can see that we're starting on the left and working away into the spindle here. So now, so let's just do, well, you can kind of see we're working on everything on 0 right here. You know, working on that ball, we can kick that over. Now another kind of cool feature we can do in here is under our tool axis control. Now instead of doing orthogonal at each position, what I'm going to do is I'm going to do follow the ISO lines, which is going to open up my advanced tab right here. Now if I click on here, this is kind of our fanning. So what I'm going to do is I'll put this at like a -30 here. Oops, -30. And what it's going to do is it's going to start fanning. And to kind of explain to you, I just kind of want to show you guys here, but let's just simulate and solid verify here. So we're kind of angling towards the spindle here, but let me kind of speed up things for not waiting here all day. Let me go to general. So it might be showing a little choppy for you guys right here because I'm showing every 200 steps. So it's just not you guys. So now we're kind of getting more towards almost the center, and you can see that we're almost straight up and down here, and it should start fanning over and the tool tilting over to more, I guess, to the left versus to the right.
Kev, you there?
Oh, sorry. Am I back there?
Yeah, you were kind of, I think you dropped off for a while.
Okay.
Sorry, I wasn't sure.
No, apologize for that. So I was trying to figure out what was going on with my machine sim here, and I was talking a bit. I'll have to look into that, and that's kind of a bummer because that machine sim was looking real cool. So I guess with that being said, is there any questions with this particular part right here? Getting, still pretty simple there, but, some different tool paths. So like I said, with that fan, we're starting going this way right here, and then it's getting more straight in the center, and then slowly working its way like this over to the side. So, all right. Any questions with this particular part right here, guys? Okay, so let's get into, dang, I'm running tight on time here. Okay, SolidCAM and recent parts, mounting bracket. Okay, so this one here is, let me just get rid of these here. So what I'm trying to achieve here is basically I want to be able to go all the way around this part right here. Now the big kicker is I got this blade right here that's in the way, so I can't get that tool just to go around and around and around. So what I need to do is really kind of play with the gouge check here. So let's just get into it here. And so for my geometry, kind of get in there and grab my surfaces. And looks like I got them all. Yep. Okay, we'll go ahead and grab my cutter here. And levels, we'll switch this over to cylinder and do 5 inches here. Toolpath parameters, I'll leave it, at my 50 thou step over here. I do want to do a spiral. And let's just see what we have so far here. So you can see we have a nice, beautiful cut starting at the top, working our way around here. Would get a real nice finish out of there. Problem is we got this guy over here, so let's just go ahead and simulate this through real quick so I can kind of show you guys. And we're really plowing through, and my tool is actually tilted completely at the wrong direction. So let's get in here and fine-tune it. So what I'm going to do is, instead of doing tilted relative to cutting condition, I'm going to do tilted to tool axis by fixed angle. And then what I'm going to do is I'm going to tell it to tilt the tool at 90 degrees. Tilt it to the z-axis. Save and calculate here. And let's just go ahead and do a simulate real quick here. Well, I didn't want to do machine sim, but let's just do a solid verify real quick and we'll save the machine sim to the end. And let's just go back to showing every step here. Looking great. Minus that minor detail right there. But, who needs that other fin, right, Steve?
That's always something. A little bit more scrap in the recycle bin.
Yep. So, so that's kind of using the tilted by a fixed angle. So it's staying right 90 degrees throughout there. Now, what I need to do is obviously avoid wiping out that other side right there. So I'm going to use my gouge check for that. So what I'm going to do for my first one is check my holder and arbor, but I'm not going to worry about my drive right now. My check surface is, let me just, it's going to be the top, and I think I have it. Let me just make sure here, the top and bottom and all the other components. So basically, you could just do, I want to tell it not to hit any of these areas that are in purple right now. And then, so what I want to do is I want to tilt my tool, and I'm going to leave it to automatic, so it's automatically going to tilt the tool to go around there. Now, what I'm going to do for my gouge 2 is same thing. We'll do holder. And now what I want to do here is I'm going to do a trim and relink. And we'll just do trim collision only, and we'll do our check surfaces as the same surface. So let's do save and calculate here. And now what it should be doing is it should be completely avoiding this area. We're going to get some bouncing around going on here, because obviously we have to go around and clear that area. we'll just see here. All right. So now you can see we're completely avoiding the center hub right here, but we're still able to go all the way around the part, getting in there and making sure that surface is going to be clean cut throughout the entire cut. We actually have just a hair of overlap inside there too, so let's just play this through here. Let's just do this one on Machine Sim. And play this guy here. So it gets close to hitting. It's going to pull up, rotate, and get the machine housing out of the way for you guys. And then come in and finish that cut. So pretty cool. And just kind of bouncing around, going around that other fin right there. And that's more, and this one, you know, as we were kind of programming this one, Greg Payton actually did this part here, kind of going through it. It's like, man, how the heck are we going to, you know, get that? And I had to play with the gouge checking a little bit there, and you know, get everything looking the way it does. So, like I said, it's, you guys got to kind of, you know, like what Justin was saying last week, you guys got to take it in steps. Don't go through the entire operation doing everything what you think would be correct. Just, you know, grab your surfaces, grab, you know, if you guys want to do a spiral or one way or how you guys want to do it, do a save and calculate. Then kind of see where your tool path is at. Then start getting a little bit deeper in. Take it in stages. Don't try to do it all at once. That's kind of where, see, the biggest thing is, you know, you guys start changing stuff in here and it's just not working. So like I said, take it in baby steps. So come in here, get your spiral set, your leave your surface quality gapped out so we're not wasting time and we can see our lines there. Do a save and calculate. Not looking good, then come to your toolpath parameters and your tool axis control and get that tool the right positioning on how we want to go there. And then keep working your way down the list here. And, you know, like I said, get that gouge check on there to completely avoid that area and, you know, rotate around so it's not hitting there as it's kind of going around and getting that overlap right there. And then the absolute last thing you want to do is come to your toolpath parameters and then tighten that tolerance up to something fairly tight so you guys can get a nice finish in there. So, okay, so we got some questions here. Let's see, usually a negative number when it comes from the opposite direction. I must have missed Ronnie. Ronnie, where was I when you were talking about that? Oh, yeah, tool tilt angle. So yeah, you guys can do a positive or negative here, and I think hopefully that's what you're getting at, Ronnie. Comes from the opposite side. Yeah. So definitely, guys, you guys can use positive and negative numbers here. So if the tool is not tilted, you know, the correct direction, we can do, what you can do is, you know, if it's tilted this way and we want it to be tilted this way, hopefully you guys can see my mouse cursor moving there, just switch it and put a negative in there. So yeah, great point. Thanks, Ronnie. This was for the previous part. Oh, Stevie, you must have been sleeping on that one.
I was. I'm sorry. Whoops. Yeah, so I'm having some trouble with my question box. I can't get the dumb thing open enough to see as it's coming in. Oh, and I've tried everything. I'm sorry.
No problem. And James, Zigzag to reduce pickups. Yeah, that actually might reduce some pickups. So let's just try it real quick here. So let's go toolpath and sorting. Let's do Zigzag. And let's see if we kind of reduce some of those. I'm just trying to think, it may not, because it's trying to go around the one circle, do it like an entire cut all the way around the surface. But let's just take a peek here. Yeah, I'm thinking we're still kind of along the same lines here. Plus blend spines. Okay. See, I'm getting all kinds of good stuff from you guys here. Let's see. So if we go to blend spline and blend spline, now as this is calculating, guys, I know I've kind of, like I said, like Steve was kind of mentioning, you know, we're not just going to help you guys on the programming side of things. And, you know, I've really had good luck with this, the Intel Extreme Tuning. It's really sped up my my save and calculation times right here. And it's kind of overclocking your computer a little bit, but definitely will help out a little bit. So for those of you guys that, I know I kind of talked about this a couple of weeks ago, but for those of you guys that are looking to just boost up your computer just a little bit, it puts everything still in safe mode because it's Intel's proprietary product here, and it's free. Just have to go to download it. If anybody is interested in it, definitely let me know. Okay, so we got, yeah, we're kind of nicking, we're kind of following the surface of this contour over here. Let's just do a simulate and machine sim here. We definitely cleaned up some of our pickup lines, but I think we're kind of maybe following the surface of that other one also. So let's just, yeah, we're just kind of slightly nicking that as it's kind of going over to follow that surface, or with the blend spline using that zigzag. So like I said, guys, this is kind of one, when you get into the more complex side of things, you got to play with it just a little bit to get what you're looking for there. But let's just go back to our toolpath and let's just try doing our spiral again here. Let's see, and then while it's calculating here, when is the SolidCAM version of code checking coming out? Ronnie, I don't know. They've just got it working with like the minor reading, like the first couple lines of code, and they're still kind of working out some of the bugs there. So it might be just a little bit, but it's coming. I don't have an exact date for you, unfortunately. Zach Prater is actually the one that kind of came up with it and did a phenomenal job on it. And he's actually going to put together a part for me, so for you guys to show you the difference. And it's more along the side of the machine sim side of things. But so what we'll do is maybe he said he may have something ready next week for you guys to show, but possibly the week after, and we'll show you guys on the difference of what it's doing there for you guys. So you really get a lot more showing movements in there, and it kind of came in the effect of, you know, since, you know, when we say, you know, simulate here and do machine sim, everything is already tilted and sitting where it should be, where with his, it's going to be, you know, everything at 0, and it's going to show you stuff moving over. So it should show you basically every single step along the way of it. So, but it's coming soon, and I'll definitely keep you guys in the loop with it. But okay, any other questions, guys? Looks like I'm still kind of rubbing against the part here, so I may have to just go to my my linking and kind of leave this at safety distance here, just to make sure I'm clearing over that. And that safety is pulling from my my levels here of that cylinder. And we're almost there. So now you can see we're clearing, not hitting on that anywhere along there, kind of clearing all the way around. So, and sorry guys, I apologize, we're running a little late here, and I had all these good, or actually Greg pretty much came up with all these parts, but had a lot of good parts here for you guys to kind of show different strategies here. But apologize for running a little late here. But any other questions, guys, on using the parallel cuts here? And like I said, next week we'll do parallel to curve, and we're gonna, like I said, we're gonna do these in baby steps here, just because there's a lot here, and I'm gonna kind of cover more of the stuff that you guys are gonna use on a common basis. So like when we were talking last week, usually these top 3 are gonna be your most popular ones. So let me just, oops. And the top 3 down here are going to be more of your common ones. So we'll stick with those, but even on this particular part right here, we switched it up to tilted by a fixed angle. So definitely going to try to show you guys as much as possible in here, get your feet kind of wet in there with the 5-axis side of things. And I may be showing some of these parts again, just doing different strategies too for you guys. So, yeah, that's basically all I have, guys, for you tonight. And before we wrap up here, I just want to make sure we don't have any other questions.
I finally got my question pane figured out, Kevin. It's looking kind of quiet. So
okay, perfect. Pull those reading glasses out and had to figure it out.
Right at the end with no questions.
No, and guys, thanks again for doing the night classes. I know this is, for some of you guys, it's late at night. I tried doing these, for a time that's going to kind of work for everybody. So West Coast to the East Coast here, and so you guys can get away from the shop and do a little after hours and just kind of sit back and hopefully get something out of it. But if you guys have suggestions, please, I can't emphasize enough, send those suggestions over. If I'm covering something too fast, let me know. Like I said, these classes are dedicated for you guys only. This is more kind of, on our own time here. This is not SolidCAM. This is kind of my little baby, I guess you would want to say. But I want you guys to get the most out of these as possible. So if you guys do have suggestions, send those over to me, and we'll get those added in. And then the last thing here is, you'll love our software. Tell your friends about it, and we'll give you 100. Yep, we'll make it worth your while. Absolutely. Mm-hmm. And and Steve, what do they have to do to get that $100 gift card?
Nothing really. If a customer looks at a demonstration, we send that out, and there's even a better reward if somebody would end up buying the software. So it's basically just contact your local representative, let us know the name and name of the person and account name, and really all they have to be doing or willing to do is accept a phone call. The one thing we caution against is just pulling out the yellow pages and say, call this guy, he could use it. It's kind of more designed around a warm handoff, if you will. So, but yeah, it's as simple as letting us know about somebody you think we can help. They look at a demonstration, you get a little spiff, and if they buy, you get even a better spiff.
Yeah, so George Lauer, you tell your buddy down the street, and from the sounds of it, all you have to do is give Steve his name and a phone number, and he sits in a demo, and you get $100. And yep. Like Steve said, if he buys the software, you get 20% of that. So the word is spreading fast out there, and we like to reward you guys for helping spread that word. So definitely, do what we can for you guys. But like I said, thanks again for watching the night class tonight and sitting in. Definitely enjoy teaching these, and I learned stuff myself doing these night classes. But if you guys, like I said, if you guys need the parts, shoot me an email and I'll get those off to you. Ronnie, send me that information for that machine, and what you need on that machine, and I'll get that information over to you also. And this is all being recorded, so it will be up on the old YouTube about 1, 2 o'clock in the morning. Like I said, any questions, guys, definitely let us know.
Thanks for the time, everyone. We definitely appreciate it and value your business.
Absolutely. Have a great night, guys.
Bye now.